Now, this lecture completes the description of the CodeWorld's V2 project, looking at the areas that you will need to write. Let's start with the body interface, which we're looking at right here. Now, this is the heart of the hierarchical world layout. It has two subclasses that we'll be talking about, brick, and then also composite body, which is not supplied. You have to write that. Brick objects represent individual cells or bricks in the grid layout, like, for instance, trees or forest and so forth. Composite body objects represent patterns like forest or stand. Now, much of the brick code is supplied, but you will still have to write the methods inherited from body. And then composite body, as I said, is not supplied at all. You have to write it from scratch. Now, let's look at the two methods of body here. The first one is getBounds, and that returns the smallest rectangle that encloses the entire body. If the body is a brick, that's just a 1x1 rectangle. But if the body is a composite body, then the bounds will be larger. And the second method, clone, returns a deep copy of the body, with all locations in the copy offset by the provided offset parameter here. This will let you set up model world patterns based on the input file, for instance, a model forest, and then use them per the prototype design pattern to crank out duplicates, placing forests wherever you would like to, for instance. Question 1 here. Given the definition of brick, what existing classes from CodeWorld's V1 would you expect as subclasses of brick? And the answer would be animal and its subclasses, and also tree. These all occupy one brick location in the grid. So implementing body's subclasses, part of brick and all of composite body, and then tying the existing animal and tree into them is one of the major coding challenges of CodeWorld's V2. And question 2, given what we just said in answer 1, how deep an inheritance tree will you get starting with body at the top? The answer would be 5 levels, as I count them at least. I think you'd have body and then derived from that brick. And then, as we mentioned, derived from that is animal, and as you know, derived from that is herd animal, and then cow or horse. So it'll be quite an inheritance hierarchy. Okay, so let's move on now to displayable and display. CodeWorld's V2 changes the display interface slightly by renaming what was update to redraw instead. And that's for reasons that will become clearer in version 3. Changes to displayable are more significant. Brick implements displayable, for instance, as we see here. And that means all subclasses, all bricks subclasses, tree, animal, and so forth, automatically do so, as they did in CodeWorld's V1. But in CodeWorld's V1, displayable needed only a 2-string implementation in order to be displayed, since all the displayables were shown as text strings in the output. In CodeWorld's V2, displayable has acquired a new method, getImage. This is what provides or produces the images that were displayed in the graphical view for each subclass of brick, the cow and the tree and so forth. And as noted earlier, most of brick's subclasses already have completed getImage methods. Now let's read those methods, please, especially those for cow and tree, and the Java docs for the library classes that they use, especially including graphics, 2D, and color. So here's cow, for instance, and there's the getImage for it. And it's using a graphics 2D, and it's using a color. Now, these methods will give you a good example of how to create images of your own for horse and sloth. There's a lot to Java image creation, but the small subset you need for this task can be copied and adjusted from the existing examples. And to that end, I have a couple of questions here. Again, subject to going and exploring a bit of what you're seeing here in the example code. First, how would I create a color object representing, let's say, a slightly greenish white? set R, G, and B components in the constructor for color to do that. And returning from a pause, something like a new color 230, 255, 230 would work pretty well. Or any similar setting with high red, green, blue components, so we're getting close to white, but a slight reduction in red and blue, so the green is a little more prominent. And you can see some other color examples here. That one, for instance, is a lightish gray, very light gray. Here we have a color that's more brownish, with that particular ratio of that much red and that much green and that much blue produces a brownish appearance, and so forth. And question 4. Given a graphics 2D named GRP, like in this example, what would you need to do to draw a circle, say at XY location 10, 20, and of diameter 5, using that greenish-white color? Now you're going to need 2 calls, and don't look for a fill circle method. Use fill oval. And returning from a pause there, I'm actually going to put this in here just for fun. We'll put it down near the bottom of the cow and make a big green blot on him. So what we would have to do is let's do a color greenish. What do we say? 230, 255, 230, and then it would be a fill oval, which will automatically use the color you just set. And what do we say? 10, 20, and then width and height of 5 each. Now, an important detail in all this is that getImage returns an image of size by size dimensions, with size the parameter that was passed to it. Now, this lets it generate zoomed-in images as needed, but it also means that all the dimensions actually are some fraction of size, as you can see, for instance, in the example code here. Good example is the eye spot, which cow's eye spot is at a x of 3/10 of size and a y of 1/4, 5/20 of size, and its diameter is 1/40 of size. And then a final item of brief note, the brick class does provide a make stipple image method. Now, this is what generates the stippled patterns for water and stone and ore. Unless you have really funny looking horses and sloths, though, you won't need it. But in later versions that have a wide variety of different building materials, it will come in handy. And our second major area here is the world factory. And this is an interface. Any class that sets up a code worlds layout implements this interface, and that includes input stream world factory, which you'll have to write and which reads the layout from a file of the format we discussed at the start of the prior segment. World factory has 2 methods. The important one is actually build, and this sets the world up. Method getWorld assumes that build has been called, and it simply returns the world as a top-level body, which of course will be a composite body unless it's a really small world. Now, separating getWorld in this way lets you repeatedly get the world without doing a rebuild or a reread of it. The main function kind of ties all of this together here in code worlds. As you can see, it creates an input stream, just like code worlds version 1 did, either from a file or from system.in, and this input stream is in turn passed to an input stream world factory constructor. The code then does a build on the constructed factory, which is where the file reading occurs, and then it retrieves the top body in the world and calls getBounds on it, printing the result. The main then creates a graphics frame. That's the graphical display we see in the demo. Or if the input is coming from system.in, then it creates a simple text printing dump display, like that in CodeWorlds version 1. When you run the program from system.in, it's expected that it's in automated test cases, and a textual output is useful for difference comparisons in that case. Now, a loop then adds all the bricks as displayables to the display that we just created, whichever one it was, and then finally a redraw command makes it show them. Now, question 5. Exactly what method of body is being called in this line of code right here to get all the bricks? Give the full header for that method. And where is it declared in the code? Turning from a pause, this should be a reminder of the whole concept of iterator and iterable. The brick class implements body, and body extends iterable, right there. And so in the iterable interface, there is a method iterator, which returns an brick iterator, and that method you will need to implement as part of body by virtue of this interface extension. Okay, that wraps up our lecture-based overview of the project. And you should now take a look at the written spec and the supplied code.